Hey folks, welcome to my channel Number Pen. So in this video, we're going to look at integral of secant x dx, right? Now we all know that secant x is nothing but 1 by cos x, and we're going to see how to solve for integral of secant x dx in this particular video, right? Now, again, I would recommend that once we solve this particular problem, you try and memorize this because this could come in handy when you solve for complex problems in integral calculus. And even if you're not able to memorize it, if you're not in a position to remember the formula, I would recommend you familiarize yourself with how we go about solving this particular problem, because according to me this teaches the power of the number 1, right? And let's see how we're going to use 1 in this particular problem. Now I know that my y, which is integral of secant x dx, I can rewrite this as secant x into 1. Okay, and then 1 is, let's say we have a number x divided by x is also 1. So 1 can be rewritten as, right, secant x plus tan x divided by secant x plus tan x, right? So we have secant x plus tan x the whole divided by secant x plus tan x equals 1, right? Now I'm going to use this and put it back in my y. And when I do that, I do see that my function inside the integral does not change, right? Why is that? Because my secant x is nothing but a secant x into 1, and my 1 is nothing but a secant x plus tan x divided by a secant x plus tan x, right? And I'm going to take that secant x and multiply it with our secant x plus tan x in the numerator, right? So let's rewrite our y. My y is now equal to integral of my secant x into secant x, which is what I have in the numerator, is nothing but a secant square x, right? And then I have a secant x into tan x, which is nothing but a secant x tan x, right? And then I have my secant x plus tan x with me in the denominator. I want you to recollect some of the identities slash formulas that we have learned in differential calculus here. I know that my d by dx of tan x is secant square x, and my d by dx of secant x is secant x tan x, right? So I do the substitution, t equals secant x plus tan x. What do I get? My dt by dx becomes equal to secant square x plus secant x tan x, right? Why is that? Because my d by dx of secant x is secant x tan x, and my d by dx of tan x is secant square x. I apply the sum rule in differential calculus, and therefore I arrive at my dt by dx, right? And this means my dt is equal to secant square x plus secant x tan x times dx, right? Now you see, basis the substitution what we have made, which is t equals secant x plus tan x, I know that I can simplify my y, right? So let's go to the next line and rewrite our y. Now take a look at the substitution that we made just now. You will notice that my numerator, which is secant square x plus secant x tan x, is nothing but a dt, right? I'm just highlighting this for you folks. Yeah. And then my denominator, which is secant x plus tan x, which is nothing but the original substitution t that we made, right? So my y becomes dt by t now. And therefore, my answer to this problem is quite simple. From here on, I get a ln of mod t plus c, right? And I cannot leave my answer in terms of t. I'll have to put back everything in terms of x. My t is nothing but secant x plus tan x. So my answer to this problem is ln of mod of secant x plus tan x plus c, right? So let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.